Hi everyone, today I'll be walking through the architecture of my ASS inbox router. The core engineering philosophy behind this project was separation of concerns, isolating the probabilistic nature of LLMs from the deterministic requirement of business logic. Now, we will scroll to the raw JSON ingestion. Here, we are injecting a batch payload of 10 unstructured emails. When I click process, the front end hits the FastAPI backend. A major technical hurdle here was concurrency because the Gemini SDK uses synchronous HTTP requests under the hood. Standard async await would deadlock the ASGI event loop during batch processing. I bypassed this by wrapping the API calls in asyncio.to thread, allowing the backend to process the entire batch concurrently without blocking the main thread. I'll click on to the process inbox. As you can see, the batch processed successfully. From a data durability standpoint, this ingestion pipeline is strictly idempotent. Every payload is checked against a process email table via its email ID. If you receive a webhook, a retry, or a duplicate payload, the database instantly skips it to prevent data corruption. We'll click on to the high priority task. So here is an high priority task from the mail, which is the Future Technology Summit sponsorship and keynote. The task has been assigned to Mira. So let's look at how the routing works. I am only using the Gemini FlashLite latest model for semantic extraction. The model is constrained by a strict pedantic JSON schema to extract variables like deal value INR and a confidence score. However, the model does not decide who gets assigned the task. The actual routing decision, like assigning this to Arti or Mira because it's an enterprise RFP, is handled by deterministic Python code. This ensures our routing rules remain 100% auditable and unit testable. We will go on to the skipped ones. Real world pipelines also face noisy data and API rate limits. Here, the semantic extractor correctly identified two emails as spammed and skipped them. Furthermore, I have implemented a dead letter queue mechanism. If the Gemini API throws a 429 quota exceeded error, or if the model returns a low confidence score, the server does not crash and the email is not dropped. Instead, it is safely persisted to a Triage queue for a human review. Now we will ask the inbox. Okay, show me all high priority tasks. So it is querying. Finally, the conversational interface. Standard RAG architectures often suffer from hallucination and massive token bloat when dumping database rows into the context window. To solve this, I implemented a text-to-SQL architecture. Here we can see the supporting data we have got. When I ask a question, the LLM acts solely a query planner. It generates a structured abstract syntax tree which my FastAPI backend translates into SQL Alchemy ORM filters. The query executes directly against the SQLite database and we only pass the aggregated integers like total deal value or task count back to the LLM to format the final sentence. This guarantees zero hallucination because the AI never infers the numbers. It only reads the mathematical aggregates provided by the database. This architecture ensures the system is resilient, scalable, and completely auditable. Thank you for watching.